Good afternoon, ma'am.
Yes, ma'am. Thank you. Okay. Till this point, we have discussed with regard to the regular languages, regular grammar, and that is for the regular languages, the generator is the grammar, regular grammar, and the acceptor is the finite automata. In the case of finite automata, the machine will know only the current state. Right. So the next we are going to move on to the next grammar, that is next level of grammar. So here your regular grammar or type 3 grammars. Okay. So regular grammars are type 3 grammars. Uh, uh, Type 3 grammars. And your regular grammar will take the form. So please make a note of it. Regular grammar will take the form alpha derives beta. So when you come across the grammars we have seen earlier, so the regular grammar will take the form alpha derives beta, where alpha is a single non-terminal and beta is so alpha is a single non-terminal. Okay. So single non-terminal and beta is nothing but beta belongs to combination of non-terminals and terminals. Okay, so non-terminals and terminals repeated any number of times. So please make a note over here. So here we are not going to. So the can you all hear me, ma'am?
Yes, ma'am. Now we can.
Okay, so beta belongs to terminals and non-terminals. So here we can have the maximum length of beta. So though it is 0 or more, so here the maximum length of beta will be less than or equal to 2. Okay, less than or equal to 2. That is, if there are two terms, then either I can have, right? So A derives Bx or A derives XB. So here X is a terminal and B is a non-terminal, right? So here in the case of regular grammar, if I am having a particular production like this, all the productions in that grammar should take this form. Okay. And similarly, if one production is there like this, then all the productions in the grammar should take this form. I cannot have a mix of this combination. Hope you can understand what I am coming up to say here. So A derives, that is terminal, non-terminal followed by terminal. So here either I can have all the productions of this format, or I can have the format in which terminal and then comes the non-terminal. I cannot have one production like this and another production like this in a particular grammar. Okay. So this is with respect to regular grammar. So here the regular grammar are called as the type 3 grammar. So now what we are going to move on is the type 2 grammar. Okay. Type 2 grammar, so which is going to be the context free grammar, CFG. Okay, context free grammar. So context free grammar. So what is the form of this grammar? So here alpha derives beta. Alpha derives beta, where alpha is a single non-terminal. Alpha will be a single non-terminal, will always be a single non-terminal, whereas beta I can have non-terminal or terminal which can be repeated any number of times. So here we are having a restriction, right? Whereas in this case, there is no restriction at all. Okay, so so type 3 we will be having higher level of restriction and type 2 will be having, so when compared to type 3, type 2 will have less restrictions and type 1, type 0, likewise it goes on. Okay, the restriction level will be reducing like this. So here, the number of terms in beta is not restricted in the case of type 2 grammar. So when we talk of the mathematical model, that is when we talk of the automata, so here we'll be discussing the push down automata. Okay. So we can start with the examples. Okay. So here we are going to start with the context-free grammar. So that is our module 4. Okay. So module 4 will be dealing with this. So here when we talk of context-free grammar, it is nothing but the generator. So I am having a language. Already we have discussed the same in the uh, during the second module, I hope. Okay. So there is a language. The generator is nothing but your grammar. Okay, generator is your context-free grammar. So here grammar. So if we talk of the context-free language, then it is going to be context-free grammar, and the acceptor is nothing but your automata, that is your machine mathematical model. So for the context free grammar, for context free language, the grammar is nothing but the context free grammar, and the acceptor is nothing but the push down automata. Push down automata. Okay. Okay. So this is the acceptor and this is the generator. So as usual, so what about the uh, if we talk of the formal definition of generator, it will have four tuples. So four tuples is nothing but the non-terminal, terminal set of productions and the start symbol. Already we have discussed with this, right? Just let us proceed with an overview, and then we can see some examples of context-free grammar. Okay, so formal definition of context-free grammar includes four tuples. So what are those four tuples? It's nothing but non-terminals. So this is non-terminals, and this is terminals, and this is set of productions. Okay, set of productions, and yes, of the start symbol. Okay, so these are using these tuples we will be defining the grammar. So when just for derivation, let us proceed with one simple example, and then we can move on how we are going to construct the grammar. Okay, how we are going to construct the grammar for a particular language. So these are the set of productions. Okay, these are the set of productions, and this is the formal definition of grammar. Okay, so the set of non-terminal is this, and set of terminals is this, and start symbol is this, right? Start symbol, yes. Okay, so here starts. So using the start symbol only, I will be proceed with the language generation. Okay, so if I want to proceed with generating a language, I have to proceed with the start symbol. Okay, so here let me proceed with the generating the string. Let me try generating the string. The particular string using this grammar, right? So what should I do? I have to start with the starting production. So we are starting with the derivation of string from the grammar. Okay, so yes derives a yes b. So this should be the, so I can choose this string or this string. Okay, so here in this case I should have combinations of a and b. Okay, two a's and two b, right? So considering that, I'm choosing this particular production, ASP. So and then what should I do? I have to proceed with, so what is my target? I have to generate this particular string, right? So what should I do? So for this, yes, I can proceed with this one. Okay. So this is going to be, so instead of this, I'm going to replace it by A, B, B. So the next non-terminal is this one. So for this, I'm going to replace it by B, and the next non-terminal is this. So I'm going to replace it by this B. Okay, so this is called a sentential form or sequential form. So what we have done, so the derivation steps, right? So it is not going to be a directly, we are not going to this particular string. Instead, we are going moving on in a step-by-step fashion, right? So this is called as sentential form or sequential form. Okay. Okay, let us start with designing the grammar for a particular language, right? So here, so here we are going to start with one language. We are going to start with some set of examples. Okay, so here our language is equal to, okay, so the language is nothing but AA, AB, BA, BB. Okay, so what can be the grammar here? So how we can write the grammar? So one way, simple way of writing the grammar, what can I do? So here in this language, only four strings are possible. So what I can do? So yes derives AA or AB or BA or BB. Like this I can write, isn't it? The thing is that S generates AA, or S generates AB, or S generates BA, or S generates BB. So this is one form of one simplest form of writing the grammar. But this doesn't hold good if the strings are infinite, right? So here finite as well, the number of possible strings is very limited. So considering that, we can write the grammar like this. How we can write the generic grammar, okay, in order to generate the string. So here, first you proceed with writing the regular expression. So how we can write the regular expression for this grammar? What will be the regular expression? Using which regular expression we can generate this string? What will be the regular expression, ma? So what is A or B? What are the strings generated by this particular regular expression?
A or B.
Can you all hear me?
It's A or will be B.
So it's equal to A comma B. So here what I need AA, AB, BA, BB. So what should I do? A or B concatenated with A or B. Do you all agree with this? This is a regular expression I require, isn't it? Yes or no?
Yes, ma'am. Yes, ma'am.
Yes. So what I can do is that, so A R B is concatenated, that is A R B concatenated with A R B. So now what can I do is, A derives A or B. Now S derives A, right? So what is the meaning? So it is equivalent to A R B concatenated with A R B. Are you clear with this example? Yes or no?
No, ma'am. Can you repeat once again?
Yes, so here A or B. So is this particular regular expression clear?
Yes, ma'am.
Yes, okay. So now what is the so what we have to do, A or B should be concatenated twice, isn't it? So what I am doing is this A or B is going to be, so for one production is A derives A or B, and next what I'm doing, so for this I have represented it by capital A. So what is next required? Again the same A should come, right? So yes derives AA. So here start symbol is AS, and my the set of production is this one, and I'm introducing another non-terminal which is nothing but A. So here A derives ARB, so ARB should be concatenated twice. So what happens? So if I proceed with this A, right? So here can I, let me try generating this particular string. Okay, let me try generating this particular string. So what I can do, so here for this particular A, I am having two choice. One is A and another choice is B. So what is my target now? I have to proceed with B. Okay, so here I can choose this particular production. So B. Okay, B, A. So what is the next one? So next A. So for this A, what I can do? I can proceed with this particular A. Is it clear?
Yes, ma'am.
Yes, the thing is that if we see more and more example, it will be clear for you. So with one example, you cannot have the full idea of the grammar. Okay. So just to see whether this particular example is clear. That's it. Okay. So the next we
Yes,
can
ma'am.
move on to another example. Okay. So this is example 1. The next example is languages A power n where n is greater than or equal to 0. Okay, so please do understand the language here. So A power n where n is greater than or equal to 0. So what are the strings possible here? Epsilon is possible, A is possible, A is possible. Likewise, it goes on, right? Isn't it? So I can proceed like this. Okay. So what is the target? I can, so in the production, I can either have epsilon. Okay. And then what about the next possibility? I can have either epsilon or I can have A, but just that A is not possible. So that A needs to be concatenated any number of times. Okay. I should be concatenated any number of times, right? So what I'll be doing is A derives epsilon or AA. So what happens here? So I can either choose this one if I want epsilon, or I can proceed with this one. So for example, let us proceed with this one. Okay. AA. So let me try generating the string AAA. Okay. So let us start with. So what I can do, so for this A, I can proceed with again this one, AA, right? And then again for this A, I'm going to choose AAA. Right? So I need only 3 A's. So, right, I can start with this. So what can I do? So for this A, I can go on with epsilon, right? I can go on with epsilon. Okay. So either I can have the production grammar like this, or I can have, epsilon or AA. There will be no change, right? So whatever may be the case, so there will be no change in the language generator. Is that clear?
Yes, ma'am.
So here we are, so please make a note, this will be used, so hereafter we'll be using this one, okay? So if I am going to repeat a particular alphabet, I'll be concatenating it with a non-terminal, so for repetition, okay? So here, let us start with this next one. So what you are going, the next language, okay? So the next language is A or B that is concatenated any number of times. Okay, so here in this language, so I have to generate the grammar for the language where I can have epsilon, I can have A, I can have B, I can have A, I can have A, likewise it goes on. Okay, so I have to generate a language for this. So please make a note over here. Here in this case, only A is going to be repeated n number of times. Whereas here, A and B can be concatenated in any combination. So here the value string can be ABBA, AABBA, likewise it goes on, right? So for that, we are going to write the grammar. So what I'm going to do, so here, yes derives, okay? So what is the, so as you all aware, epsilon is going to be one of the possibility, one of the production of yes, okay? Epsilon is one of the production of yes. And next what we can have, A can be concatenated with any combination, okay? A can be concatenated with A can be concatenated with yes. Okay, so what I'm going to do is A concatenated with yes, or B concatenated with yes, or epsilon. So here you can see, so let us take one production and then proceed. So AB, okay? So AB. So yes derives A, yes, because the first non terminal is A, so I am choosing this particular production. After this, for this particular yes, I can either go for this production or this production or this production. In this case, what should I do? I have to proceed with this particular production, right? So A, B, yes, right? So just we are generating, that's it. So here using this non-terminal. So as you all aware, non-terminal will not stop. Okay, so it will generate the language. It will proceed further. Okay, so here, yes. So what should I do? So for this, again, I can choose this production or choose this production. So, but what is the required string here? A. So I am going for this one. Okay. So the next is going to be this yes. So again, for this yes, I can choose this production or this production. So here in this case, we are choosing this one. A, B, yes. Right. So now what can I do? That's it over, right? So what can I do for this? Yes, I can replace it by epsilon. Okay. So it is terminated. So we have generated the string. So please make a note. If the further we'll be using these combinations. Okay. So if A or N to be repeated, so N number of times, if A or B needs to be repeated N number of times, I have to proceed choosing this particular sort of reductions. Okay. And then if can you all hear me?
Yes, ma'am.
It can be for 0 or more times, then we have to go with this particular production. Just make a note of it so that it will be easy for us to proceed further. Okay. Okay. So the next example is set of all strings of length at least 2. Okay. So can you please, so we are going to write the grammar for this particular language. So what we can do first, try writing the regular expression for this, after which we can proceed with the writing the grammar. Can you all please try this one? Set of all strings of length at least 2. So the minimum length is 2. So here again, we are dealing with all the input alphabets of A and B. Okay. So in all the examples, we are dealing with the alphabets of A and B. So please we proceed with that. So string of length at least 2 in the sense A or sorry. A or B concatenated with A or B will give me the string of length 2, right? And then here what is mentioned at least 2, right? After that I can have length of 2, 3, 4, 5 like this it goes on, right? So A or B star. Do you all agree with this regular expression for this particular language?
Yes, ma'am.
Yes, ma'am.
Yes, good. So for this, so already we have discussed some examples, right? So hope you can try writing the grammar for this particular one. Try writing the grammar. Hope you all have tried. Okay. So what is our target? So here, what is the thing? So here A or B is concatenated with A or B. Okay. So what I can do for this particular representation, I can choose a non-terminal A or B. A which derives A or B. Right. And next, what should I do? So here I can have S derives A. So this part is over. This part is over. So now I have to proceed with this part. Okay. So for this particular thing, I'll be having a production like this. I'll be having the grammar like this. But for this one, I have to introduce a particular production. So let me introduce B. So already we have seen this production, right? So similar this we are going to write, that's it, right? So AB or BB or epsilon. So this production will generate the language, this particular language. So what should I do? It needs to be concatenated here. Is that clear? Are you clear with this?
Ma'am, I didn't understand why we need to take a capital B for A or B clean closure.
Yes. So here you can see. So please let me repeat here. So here, what is this? So what is the constraint given? Length of at least 2, right? So string of length at least 2. So here we have given this regular expression, right? So here what should I do? I have to A or B should be repeated twice by mandatory. Okay, it should be repeated twice. There is no option at all. So what should I do? So I have, so A derives A of B. So now S is equal to S derives A, which will complete this particular part. Then what is the next restriction? So here what is the constraint? At least 2 for will this grammar generate string of length at least 2? No, it will generate the string of length 2. That's it. Okay, it will generate the string of length 2. Okay, so now what should I
Yes.
do? I have to update my grammar to make it as string of length at least 2. So what should I do? I have to incorporate this particular part. I have to concatenate. So so using this particular production, I can generate only string of length 2. Now I have to make my grammar to generate a string of length at least 2. That is length 2, 3, 4 like that. So for which I have to include this part. So for that only I'm going for another non-terminal which will generate strings of any length in the sense 0 or more. Okay, so 0 or more, A or B concatenated any number of times, 0 or more times, sorry. So A, B or BB or epsilon. So this production, this particular production alone will generate this one. Okay. So what should I do? I have to, so the effect of this production will be reflected only if I concatenate this B here. If I bring this B here. Do you agree with this?
Yes, ma'am.
Yes. Right. Okay. Mm, okay, now try to write this grammar for the language of strings of length at most 2. Okay, strings of length at most 2. First, try to write the regular expression and then proceed with it. It is a very simple one. So at most 2 in the sense, what are the possibilities? Epsilon, A, B, A, AB, like that it goes on, right? So please do try to write the regular expression for that. So epsilon should also be possible. Okay, I'll try it with. So first let us proceed with writing the regular expression. So what I need, so what are the possible strings here? Epsilon, A, B, A, AB, BA, BB, right? So these are the string possible. So for which I have to write the regular expression. So what should I do? A or B concatenated with A or B will generate the strings of length 2. So here I should also have epsilon and string of length 1, right? So A or B or epsilon concatenated with the A or B or epsilon will generate this particular language. Yes or no?
Yes, ma'am.
Yes. So what should I do? Now I have to proceed with, yes, simple one. So here I'm going to proceed with generating the grammar. So S is equal, S derives A or B or epsilon. Sorry, A derives A or B or epsilon and S derives A. Okay. So S derives A. Right. Now we can proceed with the next example where we are going to try generating the grammar, writing the grammar for the language of strings, starting with A. Please make a note over here. It is again a very simple one. Starting with A and starting with A and ending with B. Okay, starting with A and ending with B. So what will be the regular expression for this?
A concatenated with A or B enclosure concatenated with B.
A or B star B. So what about others, Ma? I feel only 2 or 3 are listening to the class. What about others? Why no response from your side? Adarsh? Adarsh Kumar?
Yes, ma'am, I'm here, ma'am, doing.
Yes, yes, listening. Okay. Ashland Viju? Yes, no, let's proceed. No, ma'am. Prekul Vyas? Prekul? Just starting the meet and then you are going to sleep, I hope. Ah, okay. Prekul, you are switching on the my unmuting, but I couldn't hear anything. So then you will say that your mic is not properly working. Prekul, I couldn't hear your voice. Prekul, I can hear my voice, but your voice is not audible. Okay, fine. Please don't waste the time, right? Just joining and keeping it aside will not be useful for you. That's what I can say, right? Okay. So yes, A concatenated with A or B star concatenated with B, right? Okay, let us proceed. So I think you can try writing the grammar for this. So here, please make a note. So what I should do, first I should have A and then next comes the A or B star part and next comes the B. So for each and every string, I should have A in the front and B in the front at the end. Okay, at the start I should have A and at the end I should have B. Okay, so the intermediate part is going to be different one. This is going to be mandatory, right? So what should I do? So for this intermediate part, I can write as A or B A or epsilon. So which will generate the language that belongs to this particular regular expression, right? Next, I have to proceed with concatenating A in the start and B in the end. So what should I do? So S derives A, B. Is that clear?
Yes, ma'am.
Yes.
Yes, ma'am.
So now try to write. So the next question is starts with A and ends with B. Okay. Starts with A and ends with B. Starts with A and ends with B, or starts with B and ends with A. Okay, starts with A and ends with B, or vice versa. Okay, or starts with B and ends with B. A. Okay, so try writing the regular expression for this particular one. So again, a very simple one, right? So in the previous case, we were having only one option that starts with A and ends with B, whereas here we are having two different options. One starts with A and ending with B, and then another is starts with B and ends with A. Okay. So the intermediate part is same. So if I represent it by means of regular expression, it is nothing but A or B star, B or B, A or B star, A. So what will be my grammar? A derives AA or BA or epsilon, and S derives AAB or BAA. So the next is starting and ending with same symbol. Okay. So please make a note over here, starting and ending with the same symbol in the sense. So in the previous case, what we discussed starts with A and ends with B, right? So the minimal length of the string will be 2. The minimal length of the string will be 2. Whereas here, starting and ending with the same symbol. So here it starts with A, it should end with B. So in the intermediate part, even if so here so the strings that belongs to the language will be A, okay, so that is starts and ends with A, and starts and ends with same symbol, and here A will also be the same, belongs to this particular language. Okay, so because starting with A and ending with A. So again, B is also belongs to this language, that is starting with B and ending with B. Please do differentiate between this scenario and this scenario. So here two different symbols in the start and end. So minimal length of the string will be 2. Whereas here in this case, the minimal length of the string will be 1. Considering that, please do proceed with writing the grammar. Okay, what will be the production? So here A is derives A. So here I'm defining the intermediate part, production for the intermediate part. So BA or epsilon, and S derives. So if it starts with A, it should end with A, right? So if it starts with B, it should end with B. Okay, and I can have A or I can have B. Okay, so this is a very simple one, right? So now so the next is going to be, now try to proceed with writing the regular expression for, writing the grammar for A part. Please make a note, only if the language is regular, we will be possible to write the regular expression, okay? So here, yes, try proceeding with this expression. A par n, B par n, where n is greater than or equal to 1. Sorry. So only if the grammar is context free, we will be able to, only if the language is context free, we will be able to write the context free grammar, okay? So here, please make a note of this language. So A par N, so this is a context-free language, so we can proceed with constructing the context-free grammar. So please do try with this particular language. A par N, B par N, where N is greater than or equal to 1. Okay, so please do try this. So are you clear with today's session?
Yes, ma'am.
Yes, ma'am.
Yes, at least two voices, no response from others.
Yes, ma'am.
Hope all are listening to the class, isn't it? Yes, again, another one voice. Yes,
Yes, ma'am.
yes, thank you, ma'am. Okay, ma'am. Please do complete this task. Okay, we can continue this in the next class. Okay, so in the next class, we will again proceed with the dealing with some examples. Okay, so okay, I have given you one task that is writing the regular expression. Writing the grammar for A power n, B power n, where n is greater than or equal to n, 1. And try, so please make a note, uh, try writing the grammar on your own. Okay. And the next is going to be for the palindrome. Okay. So for the palindrome, right? Try writing the grammar for the palindrome. So, okay. That's it with the today's session. Let me download the attendance. If you have any queries, you can please ask. Yes, I have downloaded that. Those who have queries, you can please ask, or else